Hi Geometry, this is Unit 3, Lesson 7, and we're going to start working with nested triangles. So taking a look at this diagram, I cut out these two little triangles to kind of show you what we mean by the idea of being nested. So you can see that I have triangle ABC in this picture, but I can pull apart the top triangle and pull it off, and then I have the big triangle ABC. So I have the big triangle ABC, and I also have this little triangle ADE. So sometimes we've seen our triangles drawn apart from each other separately, but now we're sometimes going to see our two triangles on the same diagram. But in this diagram, there's really two triangles here. There is the smaller green triangle that fits on top of the larger pink triangle. So let's start talking about our nested triangle. In this nested triangle, it's really a dilation. This is really triangle AED. AED is my little triangle, has been dilated or is dilated about center A. So everything's growing from this center A, about center A, with scale factor. So I need to determine my scale factor. Let's remember that my scale factor K equals an image side divided by an original side. So as I look at this picture, my image, if I'm dilating the little one, I'm making it larger. So if I'm dilating the little one, it means my side that was 4 just grew to my side that's 16. So my image side is 16 and my original side is 4. That reduces to 4 over 1 or 4. So my scale factor equals 4. So I want to talk about this for just a second as far as the 15 and the 5 and the 9 and the 3. So here's a popular mistake students make in the beginning. They think of the 15 over 5 equals 3, and the 9 over 3 also equals 3. They're going to think the scale factor is 3. But that student did not use the original side to do their calculation. So, I'm sorry, the image side to do their calculation. The image side is the entire triangle ABC. Remember my entire pink triangle? So really this entire side is actually 20. This side is 16, and this entire side over here is actually 12. My bigger triangle has sides that are 12, 16, and 20. My smaller triangle that's nested at the top have sides that are 3, 4, and 5. So you can see that whether I put my image side BC over DE, which is what I did right here when I had 16 over 4, I get 4. If I do my larger side AC over my little side AE, I have 20 over 5. That also equals 4. And then finally, let's do the other side. That is AB. So AB is my larger image side over my smaller original side, and that would be 12 over 3, or also 4. I'm not surprised to get a 4 for every single one of these because my sides are in proportion. So if I dilate my little triangle to my larger one, this side DE going to this side BC is basically a line going to a longer line. This is a segment going to a longer segment. And remember, when I do a dilation will take a line to a parallel line or itself. And this picture demonstrates both of those. So it takes this side that's 4 units and dilates it to this side that's 16, and they are parallel. It takes this side that's 3 units and dilates it to 12 total units. This is itself, it's the same line. This is a smaller segment that's 5, and it gets dilated to a side that's a full length of 20, that is itself. It's still part of itself. So if these lines are parallel, I also know my corresponding angles. If this is my transversal, my corresponding angles would be congruent. So this little E would be congruent to this C. And A is special. A is in the little triangle and A is in the larger triangle. So all three angles of the little green triangle are equal to all three angles of my larger triangle. And so in that sense, my sides are in proportion and my angles, my corresponding angles are all congruent. So if you could turn your book to page 361. On page 361, I'd like to talk about number 2. So let's take a look at number 2. It says, write 2 different sequences of transformations that would show triangles ABC. ABC is the larger one, and AED are similar. The length of AC is 6 units. The length of AC, okay. So this, all of this, AC, this entire side. So my big triangle has sides that are 4, 6, and 8. And my little triangle has sides that are 2, 3, and so there's really 2 ways to answer this problem because it does not tell me which one's original. It does not tell me that which one is original and which one then is my image. So let's start by doing it little to big. So when I do this, I'll make this one the one that's in this turquoise color. My original will be my little one, and my image, the one that's going to go to, is going to be my larger one. So in this method, my triangle is going to get larger. So when I do this, my triangle either has to get larger, and then I flip it over so it's on top of the other one, or I'm going to flip it over, and then I'm going to dilate it larger. So I think I'm going to reflect it first. So thinking of what we used to do with patty paper, I'm going to flip this little triangle over AC. You could call it AD if you want. It doesn't really matter. It's the same line. And then I'm going to dilate this line out. I'm going to have it grow until it is BC. I'm going to push this. I'm going to dilate it about the center A. So let's write that up. Little to big. So for me, my step 1 is I'm going to reflect, I'm going to reflect triangle ADE over AC, okay? And then once I have it there, I need to dilate it. So I need to dilate about center A. And then now I need a scale factor. So remember, my scale factor is a side from my image divided by a side from my original. So I could use any of them. I'm going to get the same ratio, so it doesn't really matter. So let's use the 4 from my original and the 8 from my image. And I know they go together because when I reflect this over, my side that's 4 in length, for instance, this is 4, this is 2, and this is 3. When I reflect it over, the side that's 3 goes to the side that's 6, the side that's 2 goes to the side that's 4, and the side that is 4 goes to the side that is 8. So in my image, the one it's growing to, it's 8. In the original, it was 4, and I get a scale factor of 2. That's what you'd get if you would have used the 4 and 2 or the 6 and the 3. So I'm going to dilate about, I'm dilating the little triangle, triangle, sorry about that, triangle A prime, D prime, E prime, because I've already reflected it over. So it's sitting over here somewhere. It's been reflected. So I'm going to dilate my triangle about center A with scale factor 2. And then they'll be the same. So what if I wanted to do big to little? So if I did big to little, it's exactly the same thing. So big to little. If I was going to do big to little, then I am taking my big triangle first. So I'm going to need to reflect it, or I could dilate it, because these two steps you can do in any order. But I'm going to need to reflect it over. And then I'm going to need to dilate it about A and shrink it down to be the little one. Why don't you, when you do this assignment, why don't you try to write out what the two steps would look like if you were taking the big triangle and trying to get it to lay on top of the little triangle. It's very similar to what we did up here. So then flip your page over to page 362. On page 362, let's take a look at this problem number 4. It says which figures are similar to this parallelogram. So I notice off the bat in this parallelogram, my angles are 50, 130, 50, and 130. So first of all, when I dilate something, if something's similar, my angles are always congruent. So let's go look at this. My angles are 50, 130, 50, 130. So figure A could work. It's in the running still. 130, 50, 130, 50. Yep, figure B is in the running. 45, 135. No, the angles aren't congruent. The angles are not congruent. So this one I know can't possibly be similar. 50, 130, 50, 130. Yeah, D is in the running. And then 130, 130, 50, 50. Oh, you know what? They're in the wrong order. Consecutive angles are the same here. Consecutive angles are the same here. They don't alternate. So figure E, the angles are wrong. So the angles are wrong. Okay, so that one's just a no. So now remember, if it's similar, my angles are congruent and my sides are in proportion. So my sides are all 5. So let's take a look at this one. The sides are all 5. Well, this guy is actually congruent. So being congruent is a lot like being an equilateral triangle or being a doctor. If you are congruent, you are also similar. So to be congruent is the most special. And similar then is kind of like you're just the same shape, but not necessarily the same size. So figure A is similar. It's even more special than that. It's actually congruent, but it is similar at the same time. So let's take a look at this one. Every side is 3. Yeah, that works because you know the scale factor, if I want to think about it that way, is a side from the image. So if this comes next, it's 3, and my original is 5. So B works if my scale factor is 3/5. D, 3, 5, whoa. So D doesn't work because 5 can't be in proportion with 5 and at the same time in proportion with 3. So D doesn't work because my sides are not in proportion. You can tell too it's distorted. They don't look like they're the same shape. Thank you very much.